You are standing in a San Francisco condo on the 42nd floor, 2015. The view out the window is perfect. The bay spreads below you like a painting. Your unit cost you $3.2 million. You signed the papers 2 years ago. Now, walk to the far corner. Try the door. It sticks. It binds in the frame. You have to shoulder it. Look down the hallway toward the bedroom. See that crack running the baseboards? It was not there last month. Or the month before. Now I want you to sit with this for a moment. This building is sinking. It has been sinking since the day it opened, and nobody told you. I am Dr. Hendrik Bale. I have spent my career reading what buildings do when we get the foundation wrong. My father was a structural engineer. He taught me to trust what the ground tells you first. What I am going to show you is how a $750 million landmark nearly destroyed itself. The sinking started in 2008, the moment construction finished. 18 inches down, 14 inches tilted to one side, all of it hidden. By 2016, when the truth broke into the newspapers, residents had already paid millions for the privilege of watching their building collapse under its own weight. This is the story of how that happened, and it starts with a choice made before the first beam went in the ground. You see, the architects and engineers faced a problem that day. San Francisco sits on bay mud, soft mud, the kind that compresses when you load it. A tall building there needs anchors driven deep, down to bedrock, 200 feet below street level. That costs money. Serious money. So instead, they chose a concrete mat, a thick slab sitting on sand, on clay, and nothing deeper. It was a choice that looked fine on paper. It was not. And here is what makes this story interesting. The sinking started immediately, and they measured it the whole time. But nobody saw what the numbers meant, not for 8 years. Now, the reason for that sinking goes back to one decision the engineers made about how deep to anchor and what they decided to skip. Stay with me, because at the end, there is a detail about what happened to the soil next door that changed everything. That detail is what finally forced the city to wake up. So the building is already sinking, and now I need to show you the exact moment this was decided, the choice that made it inevitable. In 2005, DeSimone Consulting Engineers sat down with the geotechnical team to design the foundation for 301 Mission Street. The bedrock beneath San Francisco lies roughly 200 to 265 feet down, buried under bay mud, soft as wet clay. Every engineer in that room knew bedrock was down there, solid, capable of holding the weight without moving an inch. But look at the two options on the table. Bedrock piles cost more money and take more time to drive. Friction piles, 950 of them, each 18 inches thick and 80 to 90 feet long, sit in the compressible mud itself. The friction piles grab the soil along their entire length, like fingers clutching sand. In firm soil, this works. In bay mud, you are counting on something that never stops moving. Here is what I need you to understand about bay mud. It is young clay, loaded with water between its particles. Under the enormous weight of a 645-foot tower, that water has nowhere to go but squeeze out, slowly, over decades. As the water leaves, the clay compacts. The whole foundation sinks with it. The design allowed for some settlement, maybe 2 inches, maybe 3. The engineers ran the math and filed the permits. The San Francisco Department of Building Inspection reviewed the plans and approved them. Friction piles were permitted under code. And there it was. The foundation system that would sink the Millennium Tower was locked in. November 2005. The Salesforce Tower, built right next door, went deep to bedrock at 260 feet. A different choice entirely. But Millennium Partners had chosen the faster, cheaper path, and 950 piles were driven down into soil that would compress for the next 2 decades. By 2009, when the first residents moved in, the building had already begun to settle measurably beneath their feet. No one saw it. No one felt it. The sinking had started. But something else was about to happen just blocks away. Something that would turn the slow compression into a crisis. So, the Salesforce Tower next door chose bedrock anchors. The Millennium Tower did not. Now watch what happens when that choice meets a shovel. In 2010, the Transbay Transit Center project broke ground across the street. That is a bus terminal. It sits mostly underground. To build underground in soft ground, you excavate. You pump the water out. I have done this work myself. The pumps run day and night. They pull millions of gallons of water from the soil around your site. You are standing at the edge of that excavation, watching water spray from the dewatering pipes. The groundwater that held the soft bay mud intact, that water is gone now. Without pore pressure, clay and silt do one thing. They collapse and compact. Think of it like squeezing a wet sponge. The water leaves, the sponge shrinks. The Millennium Tower's foundation sat right next to those pumps, 65 meters away. In 2016, residents noticed something new: doors that would not close straight. Cracks appeared in drywall, wider than before. Not random cracks, aligned with the building's lean. My measurement data shows the settlement accelerated sharply between 2015 and 2016. Before the dewatering started, the building had sunk 16 inches over 6 years. After the pumps turned on, the rate jumped. The northwest corner fell faster. Differential settlement. That is what engineers call it when one side drops more than the other. The building began to tilt like a ship settling unevenly into the harbor. Elevators bind in their shafts when buildings tilt. Utility lines rupture or pull tight. You have concrete pilings designed to carry load straight down into stable soil. But when the soil itself vanishes, when the water leaves and the mud compacts, the pilings fail to anchor. A condominium on the 42nd floor cost $3 million. The unit doors no longer closed. Residents hired surveyors. The data came back. The building was tilting visibly. By mid-2016, the San Francisco Chronicle published the first public report. That is when the silence broke. That is when lawsuits began. The dewatering was foreseeable. It was permitted. No recharge well had been installed. Nobody had re-injected water back into the ground to replace what the pumps removed. That failure, that single mitigation step, now stood at the center of the blame. And here is where the real battle starts. Two teams of engineers, each certain the other caused the collapse. With the building leaning and residents panic selling, the lawsuits arrived in 2016, and now the real engineering story had to be told in court. Millennium Partners pointed at the Transbay dewatering next door. The TJPA engineers pointed back at the shallow piles. Both were right, and that was the problem. You are in a deposition room. An expert is asked, did the building fail because of bad luck or bad design? The answer was both. The friction piles could have worked if the ground beneath them had stayed dry. Once the dewatering pulled the water away, the bay mud consolidated. 16 inches of sinking, 14 inches of tilt. The building's one fatal bet had been called. And here is the part I promised you in the first chapter, the part that changed how I read every foundation report I see. The engineers who designed Millennium Tower had access to the same soil maps I do. They knew bedrock sat 265 feet down. They chose to stop at 90 feet. Why? Because bedrock piles cost tens of millions more. Friction piles were permitted by code. The code allowed a calculated risk. And the code was written for normal buildings, on normal soil, under normal water conditions. Not a 42-story luxury tower. Not San Francisco Bay mud. Not adjacent dewatering. So the building did not fail because one person was careless. It failed because 4 decisions, each defensible alone, stacked into a tower that could not stand when the ground shifted. By 2018, the tilt had worsened to 14 inches at the roof. The Department of Building Inspection ordered a fix. Drive new piles down to bedrock around the entire perimeter. 52 new steel piles, 250 feet down, drilled through basement walls while people lived above. Cost over $100 million. In 2021, during early drilling, the building tilted another 3 inches in days. The same dewatering that had broken it was now breaking it again, even as they tried to save it. Work stopped. Engineers reset the sequencing. They learned that even the cure could wound if you did not understand the soil beneath. By 2023, the new piles had arrested the sinking. The building will never straighten. It will stand permanently out of plumb, a monument to a shortcut that cost $500 million. Now, look at what we have just walked through. A design choice, invisible failure, a trigger event, a legal reckoning, and a desperate technical answer that nearly broke the building again. The Millennium Tower teaches one lesson above all. The ground does not forgive shortcuts, but it will tell you exactly why. When you walk past a new building, look at its base. Ask yourself, did they anchor to bedrock, or did they bet on the mud? I read every comment you leave. Tell me, has this changed how you look at the buildings around you?